How are you doing, Prepperlink? Today we're going to discuss an emergency lighting system that we developed for one of our website members. The individual was concerned with having lighting, obviously, during a power outage, and being an elderly individual, he just wanted to make sure things were safe for him and his wife. So we designed a system based upon our $150 solar ammo can project, which you can watch that video. It's going to use the same type of wiring method, same diagram, the methodology of how the system works together. And again, it's a very simple way to get introduced, or at least your introduction to solar power if you're not familiar with it. The goal for this project again was to provide lighting, and when we contacted the individual, he said, well, he would just run down to the system and turn on the power. Well, we took it a step beyond that, and we provided a capability for the system to be powered by a remote control, similar to a keyless entry system for a vehicle. And we didn't want him to have to walk downstairs or walk down a long dark hallway, possibly injuring himself just to turn on some lights. So the system can be turned on and off within a 100-foot range. The product advertises 50 feet, but we tested it out and it was well over 100 foot. Alright, so for the system, you could use the ammo can project that you may have already put together. We chose to go with a different enclosure just to give us a little bit more room to wire in there and just to give it a different appearance for the project. At the end of the day, it really doesn't matter which enclosure that you use. The ammo can was cool, so that's why we went with that one initially. But for this one, we went ahead and used a conduit box or combiner box. You can purchase these from your local hardware store. Picked up this one for Lowe's. It's about 20 bucks. A little bit more expensive than an ammo can. But if you don't have access to ammo cans, you can use this system. Alright, now what we're going to do is use a LED light that we've discussed in an earlier video, and that's converting these clamp lamps to LEDs and just modifying the socket inside of here. And the reason why we went with this light is it's 2.1 watts compared to a CFL that you can get about 13 to 14 watts, or an incandescent bulb that's about 60 watts. These LEDs are going to provide enough light. It's clean, pure light as well. It's bright. It's 160 lumens for this product. The light bulbs cost about $6 a piece. The whole project costs about $15. So you can make a string of lights on a budget compared to some of the commercial products that you can purchase. To run the system throughout the house, we went with 18-2 irrigation wire, and this is single strand copper wire. Obviously there's a positive and a negative. And every 5 feet we've installed T-taps, and these T-taps allow you to plug in a device using male connectors. So basically when you clamp this on, instead of having to splice to your wire, you can just clamp these on, and this is a female adapter when it's all said and done connector, and you can just plug in your male connectors to that, and we'll show you that here shortly. So to kill two birds with one stone, instead of just providing this lighting system, we also wanted to incorporate the solar aspect to it. And so we went ahead and purchased the individual 30-watt solar panel off of eBay, one to test out, and two, for the bang for your buck. The 30-watt solar panel costs as much as about the 10-watt solar panels that we used in our earlier project. So that's shipped off to the individual. I don't have that here to demonstrate, but I will demonstrate the other aspects of the system. So now let's look at the combiner box project that we put together. Okay, again, this is a combiner box. If we open it up, you'll see the components, but before we go into the components, let's discuss the outside. At the bottom, we've purchased a clamp that we just drilled a hole into the combiner, installed the clamp, and what this clamp allows you to do is to secure your wires so you can't pull them out. So if somebody accidentally trips against it, it's not going to rip your wiring out here. Alright, on the outside, we've installed two 12-volt outlets, one for the lights and then one for general power consumption. The reason why we put a second one for lights is that this switch that we'll discuss here in a second has an 8 amp requirement, or a maximum of 8 amps, and we didn't want it to blow the switch up, by plugging in something that you shouldn't be running off of it. Alright, so in the center here we went with the eBay charge controller. It's about 15 to 20 bucks. Can't remember what we purchased that for. We have 2 power posts to run your positive and negatives to. We have the switch located in the top right. Again, this switch is powered by a keyless entry remote, and that's going to turn on the lights or turn off the lights. And again, it's about 100 foot range. And this is what the keyless entry remote looks like. It's basically an on and off switch, and I think this costs about 15 bucks from eBay, and we'll provide the links to that. And again, it's wired to one of the 12-volt outlets. The other one's on its own fuse right here, and it's wired to the other 12-volt outlet. And again, this is just for general use. At the top, you'll see the antenna extending outside of the top of the enclosure to give you that range. And again, we tested the system, the keyless entry remote, and we were able to use it from 100 feet away. At the bottom, we have the place for the solar panel to plug into, and this is a heavy-duty 2-pole connector. And we have about 3 foot of cord that goes to battery clamps, again positive and negative. And the reason why we use these is because we didn't know what type of battery the individual was going to use to power this system or to charge with. So we went ahead and installed these clamps just for practical use, and something that we can drop into place right now. So let's demonstrate hooking this system up. We're going to take the positive and negative clamps, and basically plug them to the system. You'll see right now that there's lights on the charge controller. It tells you that there's a load. Also shows your battery bank capacity, remaining capacity. Alright, if we wanted to plug in the solar panels, we'll use the ones that we have here right now. And I have 2 10-watt panels that I put on a hinge just to help me carry them around easily. Alright, and each panel has a 2-pole connector. So we can use an iMode 4-in-1 splitter, which we've discussed previously. And we're going to go ahead and plug this iMode 4-in-1 splitter. Again, it's 1-pole, 2-pole connector to 4 2-pole connectors, and this is going to allow us to plug in multiple solar panels. We're going to plug it into the solar panel port, and now we're going to plug in our solar panels to this. And again, you don't have to use this method. It's just something that works for us. And when we ship this system off to the individual, we're just going to include one 2-pole connector that he can splice to his solar panels. So it just really depends on your system. Just showing you the capability of the iMode. Alright, so that's how you would plug in your solar panels. And again, they wouldn't be located right next to the system while they could, because this is a somewhat weatherproof box. They're going to be mounted out into the sun somewhere, getting a charge. And I don't know if you can tell right now, but just this house light is providing enough electricity to start charging these batteries. While it's not much, it is providing some, and you can see right there by that light. I'm going to go ahead and disconnect the solar panels for now and move them away. Okay, next we're going to demonstrate hooking up the lights to this system. Alright, so our light port, I'm going to go ahead and plug this in. This light system, this is a 40-foot strand, as we discussed earlier. I'm basically using a Deltran 2-pole connector to cigarette lighter adapter, and I have a 2-pole connector on this light strand right here. Alright, so again, this is just modularity, so I can use this Deltran and other systems, and I went ahead and standardized all my electrical wiring using these 2-pole connectors. And before we get this plug in, again, we're going to discuss these, discuss these T-taps that we're using. They basically just clamp on to your positive and negative wires, and that's going to allow you to plug in devices without having to splice to a wire each time. And we went ahead and installed these every 5 feet to add more capability or flexibility to the system. So I'm going to plug in this cigarette lighter adapter to my 12-volt port. light port. Okay, set down the combiner box. Go ahead and take my LED lamp that we've already discussed, and I've installed male ends to this. The T-taps basically forms a female end whenever it clamps down, and you can take and install your male ends to it. Set my light over here. Okay, and basically I'm just going to take my first T-tap that I come to and go ahead and plug in my male ends to it, so you can see how that works. Pretty simple wiring method. Right now my system's plugged in, but you'll notice that the light is not working, and that's because I have not turned it on. Since this light is hooked up to the light socket and the socket's hooked up to the lighting switch, I need to take my key fob and turn it on, and I can turn it off. The reason why we use this key fob, or this keyless entry remote system, is that if there was a power outage, I didn't want the individual to have to walk down his hallway, down the stairs, whatever, to go ahead and flick on his emergency lights. This way he can keep this key fob on his keys, and when he's in his home, if there's ever a power outage and he wants some quick emergency lighting, he can just turn it on, and he can do whatever he needs to do. If he wants to unplug some of the lights to conserve power, he can now do that with a safely lit area. Alright, and again, just turn it off when you're done. So again, this is our project that we built for an emergency lighting system. Also, it has solar capability, and so again, we wanted to kill two birds with one stone here. Please let us know what you think. We'd love to hear your feedback. If you have any other ideas, any other systems that you would be interested in, maybe we can develop. We'd like to tackle those projects. Thanks for watching. Guys, have a good day. Thanks.